Question 10 says, write an equation for the function graph below. So when you're starting this, what you want to do is you want to write f of x equals a, and then draw your fraction bar. And you want to take and find your x-intercepts first. And so we can see we have an x-intercept here at x equal to 2. So I'm going to put x minus 2. You just do that by moving the 2 over as the factor on top. On bottom, you're going to look and find the different places that you had vertical asymptotes. So you can see here I have a vertical asymptote at x equal to -2. And so this would be x plus 2 on bottom. You can see here I have a vertical asymptote at 4, so that would be x minus 4 on bottom. Now, based off of how the function is performing around the asymptote tells you what kind of power you're going to put on it. Since this has the function both going in the same direction, that's going to be a squared. You can see that this has a function going in opposite directions, so it's just to a first power. Now, in order to find the a value, you now want to look at the y-intercept just to give you a really nice point, and that would be at the point 0, 1. So I'm going to use this as an xy value in order to solve for a. So I'm going to say 1 is equal to a, 0 minus 2, 0 plus 2, 0 minus 4 squared. So it gives me 1 equal to -2a over 2 times 16. So it'd be 1 equal to -2a over 32. Multiply both sides by 32. I get 32 equal to -2a, and then divide. So a is equal to -16. So you can see here, this was my answer, and hopefully this helps you to see what pieces you're wanting to pull from this graph. Your x-intercepts, your y-intercepts, your vertical asymptotes, and also how the function is performing on the vertical asymptote. Further, let's look at the next question, which was question 11. Again, write the equation for the function graph below, and it tells you the y-intercept is at 0, -0.2. So that's great that they gave that to us, because we can see we would be guessing looking at this one. So again, let's take the same approach. This one, you look and you try and find your x-intercepts, and you can see that the only x-intercept is occurring here at x equal to 2. So if I move that over, that gives me the factor of x minus 2. So again, same approach. I'm going to put the x minus 2. Now, going to talk about previous lectures and whatnot when we talked about this, since it went up and touched the 2 and came back down, then that's going to be a square. If it had passed through, it would have been 1. If it looked similar to a cubic, it'd been a 3, etc. Then we're going to look at our asymptotes. We can see at the asymptote we have x equal to -3, so it would be x plus 3 here. Again, different directions, so just the first power. Then we look over here and we have one at x equal to 3, so that would be our x minus 3. And we can see again the behavior of the function is going in the same direction, so squared. And then we're going to take and pull this y-intercept in order to solve for the a. So this would give me -0.2 equal to a, 0 minus 2 squared over 0 plus 3, 0 minus 3 squared. So this gives me -0.2 equal to a times -2 squared, which is 4, all over, let's see, 3 times 9, so 27. So a little bit different numbers here, but you're going to multiply both sides times 27, and that gives us -5.4 equal to 4a, and then divide both sides by 4. So then a is equal to -1.35. And so again, we just plug that in for a, and then we include the rest of the function that we already derived. So hopefully this repetition is helpful, and so let's just go ahead and do number 12, the last one dealing with that. So let's look at this and let's pull our information. Now on this one it's a little bit different because we do have a vertical asymptote at x equal to -1. So let me just go ahead and set up this function over here. So I'm going to say x plus 1 on bottom. We can see that the function is going in opposite directions, so it would just be the first power. I also notice that we have an intercept here at, a vertical asymptote here at 5, x equal to 5. So I'm going to say x minus 5, and again, opposite directions of the function. Next, I'm going to look and I'm going to consider what are my intercepts of my x. Well, I have 1 right here, so that means I'm going to have an x up here. No need to put minus 0. And I have 1 here at 3, so I'm going to say x minus 3. Now this one is a little bit different because this y-intercept that we have is at 0, 0. If I go plugging in zeros everywhere, it ends up zeroing out the entire top because of this 0 right here. So we're going to have to take a different approach to figure out what that a value is. You'll notice in this one that it does have a horizontal asymptote, and that's at y equal to -2. And so we're going to use that information to help us to figure this out. Since we're using the horizontal asymptote, let's revert back to what we know about horizontal asymptotes, and it goes back to the degree of the numerator and the degree of the denominator. The degree of our set numerator right now, again, just looking at this numerator here, if you were to go ahead and FOIL that thing out, you would get like an x squared plus da 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 da. If you FOIL out the bottom, you would get an x squared. And so it says when we're working at horizontal asymptotes, if the degree of the numerator was the same as the degree of the denominator, then the ratio of their lead coefficients was where you had a horizontal asymptote. Right now, we only have lead coefficients of 1, and so 1 over 1 is just 1, and that would mean we would have a horizontal asymptote at 1, but we can see we have a horizontal asymptote at -2. So if we need to create this ratio to be -2 where the horizontal asymptote would be, that means we can just make that a value a -2, and then that would give us the correct ratio. And so that results in our answer here with the -2, and we just kind of attached it into the x as a multiplier. And notice we put it on top, so this gets multiplied out, we just end up with that -2 over 1, the correct ratio. So this one was a little bit different because of that horizontal asymptote, but hopefully these examples will help.